Welcome back. So now we're going to talk about tidewater glaciers, and we're going to introduce the concept of the tidewater glacier cycle. It's only 4 slides, but those are kind of complicated slides to understand. So I hope I will make a good job at explaining all that. And don't hesitate to send me a message if that's not super clear. So tidewater glaciers flow pretty fast compared to normal valley-shaped glaciers. They mostly occur in polar regions where it's cold enough that the glacier can reach the ocean and doesn't melt away before that. The very interesting and odd thing is that tidewater glaciers can advance even when the climate is warming. While usually all glaciers tend to retreat when the climate is warming, tidewater glaciers have a very different answer to climate. It doesn't mean that they are not impacted, they are just impacted differently. Um, they lose also a lot of mass by calving. I think I said that in the first lecture. So tidewater glaciers do melt like every glaciers, but they also lose a lot of mass by calving into the ocean. So calving, again, is that process of breaking off chunks of ice at the terminus, and that ice falls directly into the ocean. So now let's talk a bit about the tidewater glacier cycle, which partly explains why these glaciers can advance during warmer climate or retreat during colder climates. So let's consider the panel A here on the left. We have a glacier that is probably a valley glacier and reaching the shoreline. It's in a stable position, meaning that it is mainly losing its ice through melt and doesn't calve that much. It might calve a bit if it's close enough to the ocean. So what happens is that eventually, at some point, this glacier will be advancing because it might have a positive net mass balance, and as it advances, it pushes some material in front of it. And that's what we call the terminal moraine, and really bulldozers its way through the landscape. And this terminal moraine can be pretty sizable, like 100 meters tall, something like that. And what it will do is it will protect the ice, the front of the glacier, from seawater. If you look at the total column of ice here on this panel, and the total column of water in this panel, and the size of the water, the size of the column of water just in front of the glacier, we can see that the water is more shallow, just right in front of the glacier than a bit further in the fjord. And that's because the terminal moraine is raising the seafloor level. So the advancing part of the glacier is creating a terminal moraine that protects it from deeper waters. At some point, it reaches what we call an extended position, and that's when trouble starts. So compared to where it was when it started advancing, you can see that a lot of that ice is actually below sea level. There's a pretty sizable chunk of it that's below sea level. So that's fine while the glacier is advancing, because it has the terminal moraine that is protecting it from deeper waters. But if it starts retreating, because maybe it's a very negative mass balance here, something like that, then the glacier will start retreating into deeper waters that it ironically kind of put itself into this situation. And so basically there's nothing stopping it from calving away and just retreating up until the retracted stable position. And that is what is represented here on the right panel. We start at the retracted stable position. The glacier is advancing and pushing its moraine. It's protecting it from deep waters, and it reaches that extended position. And at some point, a void starts opening into the deeper parts, and the glacier retreats back to where it was in the retracted stable position. And that's how you can get a tidewater glacier that breaks away super quickly in a very short amount of time. And that's also how you can have a tidewater glacier that advances even in the context of global warming. This is another figure that explains that. So yeah, there is a rapid retreat that is likely to happen once a significant fraction of the glacier's thickness is located deep below sea level. So again, we have the glacier in a stable position. That's its terminal moraine. It's going into the fjord, so the green here represents the water level. It reaches the extended position, eventually starts the retreat phase, and goes back to the shore, basically, where it is in a stable position. So which is true, which of the following is true for the Tidewater glacier cycle? I'll leave you a few seconds to answer that. So the right answer for this question is answer B. We'll go through all of them and say why they are wrong or right. Tidewater glaciers can slowly advance indefinitely. That is not true. Eventually, they will retreat. Tidewater glaciers can slowly advance into deeper water while protected from calving by the terminal moraines. That's exactly what we've been describing. As they push forward, they create that moraine that protects them from deeper waters and therefore from calving too much until they reach an extended position and start retreating again. Tidewater glaciers advance and retreat solely due to changing climate. That is not true. They can advance during warmer periods of time and retreat during colder periods of time. And finally, sediment transport plays no role in the Tidewater glacier cycle. That is absolutely wrong, because that sediment is the moraine. That is mostly due to sediment transport that the Tidewater glacier cycle is a thing. So I hope that was clear enough. Let me know if that wasn't the case, and I'd be happy to help you with that and walk you through that process again.